Hello everyone and welcome in a new video. Today we're going to solve exercises that related to chapter 21 electric current and electric circuit for grade 11 students. Okay, exercise 80, find the equivalent resistance between points A and B for the three resistors shown in figure below. So we'll notice that in this case there is two resistors 35 ohm and 45 ohm connected, or they have one point in common. So we can find easily the equivalent resistance of this group of resistors. How can we find the equivalent resistance? Simply by applying the following formula. Whenever we have two resistors or more in series, we should apply this formula. R equivalent equal R1 plus R2. Let's denote R1 for 35 ohm, R2 45 ohm, and R3 82 ohm. So in the first step, we will need to find the R equivalent for this group of resistors. Let's denote also here the equivalent resistance of this group of resistors by R12. So the equivalent resistance of the two resistors R1 and 2 is equal to R1 plus R2 since they are in series. Substitute the values. We have R1 is 30 ohm, 35 ohm, and R2 is 45 ohm. So we will get that R12, the equivalent resistance of R1 and R2 is equal to 80 ohm. Now let's redraw our electric circuit. We have here R12, the equivalent resistance of R1 and R2, and we have here the third resistor, which is equal to 82 ohm. Notice that here R12 and R3 are connected in parallel because they have 2 points in common. This is the first point and this is the second point. So since we have two resistors in parallel, we can find the equivalent resistance of this group of resistors by simply apply R equivalent R1 times R2 in general, R1 plus R2. So R equivalent of this group of resistors is equal to R1 2, the first resistor is R12, the second one is R3 over R12 plus R3. So R equivalent is equal, substitute the values, R12 is equal 80 times R3 is equal 82 over 80 plus 82. Plug this in the calculator, we will find that R equivalent is equal 40.5 ohm, the equivalent resistance of this electric circuit between points A and B. Okay, let's solve another exercise, exercise 82. Find the equivalent resistance between points A and B in figure 21-27, given that R is equal 62. So the resistance of R is equal 62 ohm. We will notice that we have a complex situation here. Complex electric circuit consists of three resistors. We need to find the equivalent resistance of this grouping. So we need to divide our calculation. First of all, we're gonna find the equivalent resistance of this group of resistors. Then we will find the equivalent resistance of the whole electric circuit. We will notice that in this circuit we have These two resistors are in parallel since they have 2 points in common. This is the first one and this is the second one. Since the first terminal of 75 ohm is connected to the first terminal of R and the second terminal is connected at this point with the second terminal of R, then they are in parallel. How can one find the equivalent resistance of these resistors? We simply apply this equation. R equivalent for two resistors in parallel, R1 times R2 over R1 plus R2. Let's apply it. So R, let's say this is R prime, the equivalent resistance of this resistors is equal to R1. This is R1, let's say this is R1, this is R2, and this is R. So here R2 times R2 plus R. So it's equal to R2 is 75 ohm times R is given 62 ohm over 75 plus 62. R prime is equal, plug this in the calculator and we will get the answer, and the answer is 33.95. What does R prime represent? R prime represents the equivalent resistance of this grouping of resistors. So we need to redraw our electric circuit. This is R1 and this is R prime. Now we can find the equivalent resistance of this group of resistors. We will notice that R1 and R prime are connected in one point. They have one common point, so they are in series. Whenever we have two resistors or more in series, we will apply the following formula in order to find the equivalent resistance of these resistors. So R equivalent in general is equal R1 plus R2. Since R2 is R prime, we're going to replace R2 by I prime. So R equivalent of the electric circuit, of this electric circuit, is equal to R1 plus R prime, knowing that R1 is given here 24 ohm, and we already calculated the R prime, which is equal to 33.95. Plug these values in the calculator, you will get what the equivalent resistance of the whole electric circuit, which is equal 57.95 ohm. Okay, let's solve another exercise. Exercise 86. Find the equivalent resistance between points A and B in this figure. We have also here a complex electric circuit consists of 6 resistors. We're gonna denote, for simplicity, each resistor by R1, R2, R3, R4, R5, and R6. Okay, we will notice that in this electric circuit we have 3 resistors in parallel. Since they have one common point on the left hand side, and we have also here one common point that connects each of 3 resistors together. So since we have 2 points in common, then this combination is, or these resistors are in parallel. We know that for resistors in parallel, we can apply this relation, but in this situation, in this case, we have more than two resistors, so we cannot apply this formula. We need another formula. This formula is suitable for this case. R equivalent is equal 1 over R1 plus 1 over R2 plus 1 over R3. This is the general form to the power minus 1. We will use this formula whenever we have more than two resistors in the electric circuit. We have here, we need to find the equivalent resistors of this group of resistors, and we know that there are more than two resistors, so we will need to apply this formula. So let's apply this formula on this group of resistors. R equivalent is equal 1 over R3, this is the first resistor, plus 1 over R4 plus 1 over R5 to the power minus 1 equal 1 over R3, 1 over 4.8 plus 3.3, 8.1 to the power of minus 1. Plug this in the calculator, we will find that the equivalent resistance of this group of resistors is equal to 1.57 ohm. Let's try to redraw this electric circuit, knowing that we should replace this 3 resistors by the equivalent resistor. Okay. And I'm gonna replace the I'm gonna denote the equivalent resistance of this group of resistors by R prime for simplicity. So we have here R1 and here R2, and the equivalent resistance or resistor of the 3 resistors is R prime, and also we have R6. Notice that R prime and R6 have one point in common, only one point. They are connected in one point, so they are in series. Whenever we have resistor in series, we should apply the following formula in order to find the equivalent resistance. The formula is R equivalent is equal R1, R2, we simply add them together. So the equivalent resistance R double prime, which is the equivalent resistance of this group of resistors, is equal R prime plus R6, which is equal to R prime is 1.57 ohm, as mentioned here. We already calculated. Okay, plus R6 is 6.3 ohm. Plug the values in the calculator, we will find that the equivalent resistance is equal to 7.87 ohm, R double prime. Now, once again, we're gonna redraw our electric circuit as follow. We have here R1, R2, and the equivalent resistance of this group of resistors, which is R double prime. It doesn't matter the position of R prime. We can draw it like this, or even like this. horizontally or vertically. So R prime, R1, and R2. Notice that this group of resistors are in parallel since they are connected in, or they have 2 points in common. This is the first point. This is the first point that connects R2 with it, and this is the third, terminal that connected to the first point. Also, on the other hand, we have this terminal connected at this point, this terminal at this point, this terminal at the same point. We have same point in common. So we have 2 points in common as a result. Whenever we have more than 2 resistors in parallel, in order to find their equivalent resistor, we need to apply this formula. R equivalent is equal 1 over R1 plus 1 over R2 plus 1 over R3, and don't forget to raise it to power minus 1. So R equivalent is equal for the whole electric circuit 1 over R1, the first resistor, 1 over R2, the second resistor, and 1 over R double prime. This is double prime, I think, not R, double prime, not R prime, to the power minus 1. Substitute the value, the resistance of each resistor. 1 over R1, R1 is equal to 1.5 plus 1 over R2, R2 is 2.5. We have already calculated R double prime in the previous step, and the equivalent resistance, or the value of this resistance, is 7.87. Plug these values in the calculator. Don't forget to raise it to the power minus 1. You will get the equivalent resistance of the whole electric circuit, or for this circuit, which is equal 0.84 ohm. Thank you for watching the video. See you in the next video soon. Bye bye.